So I'm going to talk about a history of the Mortlake Gasworks and the 3-foot gauge railway system that was at the gasworks, and also the Telfer system that replaced the 3-foot gauge railway. But the Telfer system and the railway worked in conjunction for a period of time as well. So it wasn't just a simple matter as the Telfer starts up, therefore the railway is over. For the engineers amongst you, because I had this question asked me once before, what's the box in the middle of the photograph? And I'll put my arrow on it at the base of the chimney. That is the purifiers. And these consist of boxes filled with iron oxide, and the lids are sealed in a trough of water. So the raw gas would be pumped through these boxes, and the sulfur impurities would be absorbed by the iron oxide. So it's just part of the purification process.
Does it?
Righto. The Mortlake Gasworks was operated by the Australian Gaslight Company, and AGL was formed in September 1836, and it erected a gasworks at Kent Street in Sydney, in Darling Harbour. And this is the Kent Street Gasworks. On the 24th of May, 1841, to use the quote, one of the most important innovations of the modern times arrived in Sydney when the city was illuminated with gas for the first time. But with the expansion of the city to the west and the south, it became more and more difficult for Darling Harbour to supply gas to the outlying suburbs. So new gasworks were erected in Balmain in 1875 and Five Dock in 1881. But they were only really a stopgap measure because they needed a major new gasworks. So they searched for a site on the Parramatta River, and they wanted a site on the Parramatta River so that the coal could be shipped from Newcastle straight to the coal works, the gasworks, sorry. So the land was purchased in September 1883, and construction of the number 1 retort house commenced in late 1884. All the major plant and equipment used at Mortlake was imported in the United States. Now, the building, that main part of the building in the middle there is the retort house, the number 1 retort house, and the 2 buildings on either side of it are the coal stores. And they were 40 feet wide and had a capacity of 5,000 tonnes of coal each. In the retort house itself, there was 276 horizontal retorts. And the first gas was produced on the 23rd of May, 1886, and the number 1 retort house closed in 1929. To deliver the coal from the wharf to the number 1 retort house, in May 1886, a locomotive and trucks were ordered from England for use on the internal railway. This was a Hudswell Clark 040 ST, builder's number 282, and was shipped from England on the 7th of August, 1886. And all the Hudswell Clarks didn't have cabs, and all the locomotives purchased for the Mortlake Gasworks, apart from a Davenport, which was purchased in 1917, were to this identical design. The number 74 was a later addition because they actually named all their locos except for this one. So the way the system worked was coal was shipped from Newcastle, or more precise Hexham, and delivered to the company's wharf at Mortlake.
You're right.
At Mortlake, that you can see there in the photo the tubs. These had a half-ton capacity, and they were loaded by hand. And then they were lifted out of the ship's hold using steam cranes, and then manually tipped into the hopper wagons that actually worked on the railway. So you can see one of the Hudswell Clarks in the foreground, and a number of, because there was double track on the wharf, so you can see hoppers in the background loaded with coal, ready to be shunted to the retorts. there was a 2-level railway. The top level was for supplying coal to the retorts, and the bottom level was for taking ash and coke out from the retort house. So you can see here the high-level railway that went into the 2 coal stores, and then the railway, there was a railway system at ground level that took away the coke and the ash. The elevated railway was on a curved viaduct, 20 feet high, built of cast iron columns and wrought iron girders, and it was ordered from England in May 1885. Within a month of Mortlake having commenced operations, the company's engineer stated that it would be necessary to commence at once, making preparations for the winter of 1889. And this involved building the number 2 retort house, which is the right-hand retort house, and the number 2 gas holder. And they were completed in November 1888. But his forecast about needing more gas, they didn't need to produce that much gas that soon. So it's not until 1892 that the first retorts were installed in the number 2 retort house. Right, now, in the early 1890s, there was the maritime strike, which was a major, almost dropped my notes, that would have been a disaster, which was a major, basically national strike. So there were strikes on the coal fields, amongst the miners, as well as all sorts of industries. So after the strike was over, the board of AGL wanted to be able to store more coal at Mortlake. So if this happened again, that they'd have a bigger reserve at Mortlake. So the plan was to store coal in the coal stores in the number 2 retort house. If you see my cursor here, the 2 openings here in the back of the coal stores of the number 1 retort house, that's entrances for the railway. And same again here, entrances to the railway here. So the aim was to build another wrought iron viaduct that would join the coal stores in the number 1 and number 2 retort houses. So tenders were called for that in December 1890 for the wrought iron railway viaducts. But the quotes submitted by local firms were too high, and the iron work was ordered from England instead. At the same time, AGL ordered its second locomotive on the 3rd of February 1891, once again from Hudswell Clark, which was builders number 385, and this was called Kangaroo. Because of the length of time it was going to take to get the wrought iron viaducts from the UK, the works engineers suggested that a temporary wooden viaduct be erected between the 2 coal stores. So what he proposed was that the temporary wooden viaduct be erected between the 2 coal stores on the eastern side of the 2 retort houses. And then when the eastern coal store on number 2 retort house was filled, that pull down the temporary viaduct, relocate it to bridge the gap between the coal stores on the western side and fill the western side. So they did that, and then they had another problem. They had a fire in the coal stores in the number 2 retort house because of spontaneous combustion. So the instruction was then not to store coal in the number 2 retort house. Now, in the foreground, you can see this crane. So zoom in on the crane, you can see there's a bit of interesting dual gauge track. So it's possibly a standard gauge hand operated crane, because the railway system at Mortlake was 3-foot gauge. So there's a 3-foot gauge section of track and an extra length of rail here that suspiciously looks like bullhead rail that's laying on its side to create a grooved track for the other set of rails on the crane. Now, this is a plan of the works later than what I'm talking about at the moment. So here's the number 1 retort house. Here's the number 2 retort house. Over here is the coaling wharf. Then you've got the elevated viaduct to take the coal into the coal stores. And you can see where the viaduct is. And then it loops round the back through the coal stores on the other side. Well, it actually looks like it runs beside and joins up there again. And there's a separate track going into the coal stores. Down here are the number 3 and number 4 retort houses, which I'll talk about later on. But possibly up here is a loco shed for the locos. This has been the only plan I've been able to find so far of the Mortlake Gasworks that shows the railway. So unfortunately, as you can see, it's not the clearest of plans, but it gives you an idea of the gasworks and how it worked. Now, in 1914, they decided to install a Telfer system to handle the coal to the new retort houses. This was ordered from Adolf Blichert and Company in Leipzig in Germany. And on the eastern side of the number 1 retort house, a battery of 6 electrically driven coal breakers was erected. So the coal breakers are in this bunker system. So a branch line from the elevated railway then connected the coaling wharf to the coal bunkers, and the coal bunkers then supplied coal to the Telfer system. And there were 2 Telfer systems, one for handling the coal that was being supplied to the retorts, another one used for handling the coke that was the byproduct of retorting the gas. Now, where that coal bunker is, there's a collier sitting at the coal wharf. There's the number 2 retort house, and it's in there beside the number 1 retort house. And once again, they're the number 3 and number 4 retorts. So the Telfer system was erected in conjunction with the number 3 and number 4 retort houses, which were vertical retorts, not horizontal retorts. Now, a Telfer system works on a block system. It's a monorail system, so it's divided into electrically separated sections of track. So as a Telfer truck passes on to a new section of track, the block section of track behind it is electrically isolated. And then when that Telfer truck reaches the next one, the power is restored. So if you've got 3 blocks A, B, C, as it goes from A to B, the power is isolated to A. Then when it goes from B to C, the power is restored to A, but the power is then isolated to B. And that's designed so that you can't have the problem of a Telfer truck running up the backside of another one, that they're always separated by a block. To raise Telfers from one level to another, they go up spirals. And this is the spiral here in the middle of the photo between the number 3 and the number 4 retort houses. What would happen is a Telfer truck would come in on the lower level and it'd get to an electrically isolated section of track. In the middle of the spiral, there's a rotating arm. In the rotating arm, it'd come up, press up against the rear of the Telfer truck, then push the Telfer truck up the spiral, up till it got up to the next level, and then it'd be pushed onto a section of track that was again electrically operated. And then it'd set off on its journey again. The Telfer system at Mortlake lasted until 1962, when it was replaced by a conveyor system. In answer to a question that's probably going to ask, there are switches in a Telfer system. Now, I don't know if Mortlake use switches, but this illustrates a standard Telfer switch. It's called a Strawn and Henshaw patented top rail switch. So you can see electrical cables. What this is here, the next slide will show the switch closed. This is a stop block so that if something goes wrong, a Telfer truck can't come sailing along and go over the gap. And so there you can see there, the switch is closed, the stop block is raised, and the Telfer truck can then continue on the monorail system that way. This is a standard Telfer truck at Mortlake. They had a capacity of 2,200 weight of coal. They could be set up to, if you wanted to unload coal in the number 4 coal bin, there was a magnetically operated ratchet which controls the retaining catch of the Telfer trucks. A fixed indicator behind the ratchet wheel is numbered to correspond with the required discharging points. So when it was loaded, an operator had put the ratchet to say number 4 bin. So the Telfer truck would go over number 1 bin, and there were short lengths of trolley wire fixed over each discharging point and an auxiliary collector. The collector would energize the solenoid and the ratchet would then move 1 notch. Go over the number 2 unloading point. Once again, solenoid activated, moves the 2nd notch. Number 3 bin, solenoid, 3rd notch. When it gets to the number 4 bin where you want the coal, the solenoid then activates the doors to be opened. Now, in 1919, major extensions were started at Mortlake. This is the number 2 coal wharf, which was built in Kendall Bay, which is on the eastern side of the Gasworks. And electric grab cranes, which you can see here, were installed. And a conveyor system was also installed to take the coal to the Telfer system. But as you can see, there was also a fallback system of having the Gasworks railway laid up the middle of the wharf as well. So if they had problems with the conveyor, they could go back to the good old-fashioned system. The electric grab cranes were capable of unloading 75 tonnes of coal per hour into the hoppers on the railway system, or alternately onto the conveyor system. Sorry, I'll just actually have to rephrase what I've just said. That is one of the electric grab cranes. That was the original system setup. So the grab cranes would do similar to what was done in the number 1 coal wharf. Rather than having tubs filled by hand, the grab cranes would grab the coal out of the bunkers on the 60 milers, as the colliers were called, and can put them into the railway system or the conveyor system. In 1935, they erected 2 transporter grab cranes, which are these 2, one behind the other here. And they would then unload the coal from the ship's holds, and the conveyor system would solely then be used to transfer coal to the Telfer system. 2 of these electric grab cranes were removed and taken to AGL's Blackwattle Bay coke depot. So the coke produced at Blackwattle Bay would be loaded into lighters, taken around to Blackwattle Bay, then unloaded at Blackwattle Bay, and it would be sold. You could buy a bag of coke. There's a photo I saw where they're actually using sugar bags, loading sugar bags with coke to sell to people. Another big user of coke was actually Sydney ferries, because the steam ferries used coke rather than coal. In 19... Right. Oh. Righto. In 1917, they once again extended the Telfer system at Mortlake. And because Adolf Bleachert and Co. was a German company, they weren't going to buy anything from Germany. So an engineering company in Sydney called Poole and Steel built the extension of the Telfer system. At the same time, they wanted an extra locomotive, but because all the UK locomotive builders were tied up in the war effort, they couldn't get a loco from Hudswell Clark or any UK company. So instead, they purchased a locomotive from Devonport in the United States. The only photograph of the Devonport loco is one of it being scrapped. And if anybody ever comes across a photo of this Devonport loco in service, I'd love to see it. I spoke to Bruce McDonald, if you know Bruce, and he thought he'd seen a photograph of it in the Mal Park collection, but it hasn't survived, or if it is, it's in a part of the Mal Park collection that's in private hands or who knows where. After the First World War, they wanted another locomotive, so they decided to build a locomotive in the workshops at Mortlake to the standard Hudswell Clark design. And this locomotive was called Phoenix. There's been one reference saying it was built out of spare parts, but that can cover anything from just simply spare injectors, safety valves, spare set of driving wheels, and everything else is built at Mortlake, to a company like Mort Stock could have built the boiler. The workshop at AGL is in this photo, and it was described as being well equipped with workshops for all trades. The design being that the work should be as far as practical, self-contained and self-supporting. All repairs are executed and carried out on the works, and all new construction work, though perhaps not fabricated on the works, is erected by the work staff. So it had an extensive workshop there, including a steam hammer and all that sort of stuff. So it is possible that the majority of the locomotive was built at Mortlake. The last locomotive purchased by AGL was another Hudswell Clark, which was ordered on the 7th of April, 1925. It was Hudswell Clark Builders number 1560, and it was named Concord, and it was number 72. And the numbers they were given don't correspond to the order in which they were purchased. So the first loco they had was number 74, and the last loco they purchased was number 72. So it was some internal numbering system that they came up with. The internal railway system continued to operate until 1948. And it was at that stage used for transporting coke to a coke dump at the works that wasn't accessed by the Telfer system. And it was also used for general transportation around the works. As I said, it closed in 1948, and in August 1948, the company called tenders for the purchase as and where they lie at the company's Mortlake works of steam-driven locomotives, trucks and spare parts, comprising 3 steam-driven locomotives in good running order, 62 trucks, spare parts for locos and trucks, 3 locos without boilers, and the chassis of which are in need of repair. Now, the ultimate fate of the surviving 3 locomotives is unknown. In October 1949, it was reported in the ARH Bulletin, they were stored at Trailer Park, Waterloo, New South Wales, in the questionable company of motor trucks and trailers. So the 3 locos that survived were Concord, Ivanhoe, and Phoenix. And what happened to these 3 locos, because this is the photo of them at Waterloo, after they spent some time at Waterloo, I have not been able to find out. Now, going back in time a bit, this is, I think there's 5 of the locos from memory in this photograph. This is the upper railway from the coal wharf to the coal bins and the retort house. So you've got 1 loco there, got a 2nd loco there, 3rd one there, a 4th one there, and a 5th one there. So in 1937, this viaduct was demolished and the number 1 coal wharf was demolished as well. The coal stores in the number 1 retort house were rebuilt and were turned into dining and locker rooms. And that, I went to the Mortlake Gasworks, when would it have been? In the 1980s, when it shut down, but there were still remains of the 3-foot gauge railway system in the roadways. They went from horizontal retorts in the number 1 and number 2 retort house to vertical retorts in the number 3, 4, 5, and 6 retort houses. And they also then set up carbureted water gas plants. And a CWG plant works by heating coke and injecting oil into the heated coke to produce a gas. So it was a win-win for the gasworks because, as I said, coke was a byproduct of retorting coal. So they could then use the coke to produce gas, and a CWG plant could be fired up faster than a retort house. So if there was a sudden demand for gas, they could quickly fire up a CWG plant and meet that demand. The Mortlake Gasworks, in its greatest extent, was the biggest gasworks in the Southern Hemisphere. The number 4 gas holder at Mortlake was something like the 2nd biggest gas holder in the world when it was erected. So the Mortlake Gaswork was a very large undertaking in its heyday. And all that's left now is a handful of the original buildings, and it's all been subdivided and turned into blocks of flats. So that's the story of the Mortlake Gasworks Railway and the Telfer system. So I'm now assuming Mike's going to tell me to press the button that says stop share.
That's right, Mark, and we'll pass back now to Bill.
So hopefully I've stopped sharing.
Yeah. Well, Mark, that was very interesting. And what a magnificent photographic collection.
Well, in the State Library here is the director's minutes books from the 1880s until the early 1920s and the photographic collection. And there's over 1,000 photographs in the photographic collection. And I've looked at all of them, and there's very few photos of the gasworks. A lot of them are, photographs of products, how, for advertising and all that sort of stuff. And I knew this photo, the last photo, I knew it existed because I'd seen it published in a book. And of course, it was the 1,001st photograph I looked at before I finally found it.
Yeah. Oh, no, they're terrific. They're very clear photos.
Yep.
Very sharp. No, but yeah, no, fascinating story. And as you were going through the presentation, it reminded me of the West Melbourne Gasworks here and some of the similarities, even though West Melbourne was much smaller. But yeah, it's just similar practices on some of the things. Yeah, no, very interesting.
Yeah, so as I said, one of the big traditions of Sydney Harbour was the 60 milers. And they're called 60 milers because it was 60 nautical miles from Newcastle to Sydney. And they ran a shuttle service delivering coal to the gasworks and other users in Sydney. And they were a big tradition of Sydney Harbour, basically until the gasworks closed. And shortly before the gasworks closed, well, the gasworks, it stopped retorting coal and it became a distribution centre for natural gas. And when it stopped retorting coal, that's when the last 60 miler ran, and a big nautical tradition of Sydney came to an end. Yeah. And one of the ruins, the wreck of one of the 60 milers is actually in Homebush Bay.
Okay. All right. Anybody got any questions for Mark? Stony silence.
So I was listening to you, but I Google while I'm listening. So is this the same one that's got the Great Strike of 1917? Is that the same Gasworks?
Yes. The two photos early in the piece showing them shoveling coal into the tubs and on the coal wharf, they're actually photographs were taken during the 1917 strike, and they're volunteers manning the railway and manning the shoveling coal into the tubs. And I've got another postcard view which shows a camp for the volunteers in front of the gas holders at Mortlake. So yes, it is the same Gasworks.
Right.
Yeah, I've got a picture here, and I just don't know what it's of. It's just got a rather large cylinder, but it's got no walls. So I suppose that's all part of the
It looks to be the gas holder.
Yeah, I'd say that'd be the gas holder. Can you hold the photograph up? Oh, you can't.
Yeah.
Because
Just hold it up. We might be able to see it.
yeah, that's the gas holder. That's one
Yep.
of the 4 gas holders at Mortlake. So they were actually a telescopic system. The sides of the gas holder actually went into grooves, for a better time description, cut in the rock, and the grooves were filled with water to produce a seal. So as the gas holder filled with water, it raised up, like the columns, there were rollers on the side of the gas holder. So as it filled up, it would raise up. And as gas was taken out of the gas holder, as the gas holder lowered down, it would maintain the pressure in the system to an extent.
It's got another picture here of Mortlake Station that's got 2 of the gas holders, and it's got the resident engineering cottage next to it. So yeah, it's very interesting.
Yeah. I note that Roderick Smith has got a hand up.
2 questions. At maximum, how far was gas reticulated from Mortlake? Sydney grew so much after post-World War II. What was the extent of original reticulation?
There was the North Shore Gasworks at Waverton, which covered the northern parts of Sydney, but Mortlake provided gas out to Parramatta and, the southern suburbs of Sydney. There was another gasworks at Parramatta, but AGL took it over and shut it down and supplied gas from Mortlake. The Kent Street Gasworks was eventually taken over by the state government to expand the wharfs in Darling Harbour. So gas went to the eastern suburbs, the southern suburbs, out to Parramatta. There were gas holders in strategic locations around Sydney. So gas would be pumped to those gas holders, and they would act as reserves and supply gas that way.
Anywhere really, 1930s Sydney was served with reticulated gas.
Yep. AGL was, of course, it's called the Australian Gaslight Company because it was set up to provide gas street lighting in Sydney. And the last street lights supplied with gas were disconnected from the system in something like the 1920s in Ryde or somewhere like that. So.
And the other question, you mentioned retorts 5 and 6 in one of your maps, but I don't think your talk mentioned the construction of 5 and 6.
No, because they were, I was mainly concentrating on the Telfer system and the railway. So 5 and 6 were set up from 9. They didn't build the retort house in one go. So the number 5 retort house, they might start in, say, 1920, and build, 100 retorts. And then the ultimate design of the retort house might be that it had 200 retorts in it. So it wouldn't be completed with all retorts until maybe 4 or 5 years until construction started. So as they needed more gas, they would do a stage construction of the new retort houses. As I say, the number 3 and number 4 were the first vertical retort. They had Glover retorts, I think it were, in them. And then the 5 and 6 were the same.
Mm.
Cool.
Oh,
Mark, so you say the gas was used for street lighting and it was last used in the 1920s. So what did they use the gas? Was it used for domestic housing use?
Yes,
Or?
it was, as I say, from just being gas lighting, it then extended into domestic use. Like gas lighting was the next step. The more wealthy would have gas lighting in their houses rather than having candles and kerosene lamps. Then it was gas heating, gas stoves, and yeah, so you could have a gas hot water system, you could have a gas heating system to warm the house, gas stoves, and it just depends what you wanted in your house that would be connected to your house. And there are also systems like a penny in a slot system that rather than having the gas connected permanently like you do now, you'd put a penny in a slot and that'd turn on the gas for, half an hour and you could cook your dinner or something like that. But the more wealthy people would have a meter, and it'd be like how gas is connected now, going through a meter, and you'd have meter reader come around and you'd get a bill from AGL.
yeah.
You could have gas refrigerators as well.
Yep.
Silent night gas refrigerators were fairly popular.
Yep, the Holstrom Works in Narembeen. I grew up in Willoughby, which is just a couple of miles from the Holstrom Works, and I remember as a kid it was still there and still manufacturing refrigerators.
Mm. Yeah.
Lots of
Mark,
flats.
do you know if there was a railway system at the North Shore Gasworks at Waverton?
No, there wasn't. It was a smaller gasworks than this. And once again, I went to the North Shore Gasworks just after it closed, and I didn't see any trace of a railway system there. So, and there's been no report of a railway system.
Yeah. No.
Yes, I used to be in the fire brigade, so I used to be able to go to all sorts of interesting places as part of our duty. Just knock on the door and say, "Can we have a look around?"
I don't know if you're receiving me, but could you give us a potted history, if you like, or description of what actually happens in the retorts? What is the process?
The retorts is just a closed vessel, and there's external heating of the coke, and it drives off, not the coke, of the coal. And because it's a closed vessel, the coal doesn't actually catch alight. It off gases the volatile gases contained within the coal. Then there'd be a exhauster which would suck the gas out of the retorts. And then, as I say, the exhausters would then pump it through the purifiers, which are in the early part of it. And there are other couple of steps in it to remove the impurities from the gas. It's the same process as at a shale oil works, except at a shale oil works, they put shale into the retorts, heat the shale to produce gas that is rich in crude oil. And then the gas in a shale oil retort then goes through a condenser to condense the gas out of it. So the system's basically identical between a gas works and a shale oil works. It's just that they're producing a different product.
Can I finish with a story of my life? In the 1960s, I was working in London, and we had a gas meter that you had to put shilling pieces into, but you can never find one because every shilling piece in England was inside gas meters.
Yeah.
Well, I might add too, like at a gasworks, they just didn't put coal into the retorts. At Mortlake, I think it was 5% shale and 95% coal, because the shale would increase the illuminating capacity of the gas that was produced. But shale was too expensive to put 100% shale to produce gas. So they enriched the coal with shale to enrich the gas.
Okay. Interesting.
Places like Hartley Vale, the high quality shale didn't go through the retorts at Hartley Vale. It was either exported overseas or sold to Gasworks. And it was the second grade shale that went through the retorts at Hartley Vale, produced crude oil, and that was then refined into kerosene and lubricating oils and all that sort of stuff.
Yeah.
Because I'm also writing a history of Hartley Vale. So that's how I can tell you about how the system works at Hartley Vale as well as at a gasworks. And when they set up the carbureted water gas plants at Mortlake, they called tenders for the supply of 1 million gallons of oil per year. And the New South Wales Shale and Oil Company, who operated Hartley Vale, got the contract, and they set up new retorts at a place called Torbane to produce crude oil that would then be shipped to Mortlake to be used in the carbureted water gas plant. So there was a connection between the two processes in that regard.
Yeah, all very complex, but intertwined everywhere. Yeah.
And there's no trace really left of either of them anymore.
No. Something people ask, somebody asked what was all the gas used for, and because it started off as street lighting. I remember years ago here in Melbourne seeing some old terrace houses being demolished down in South Melbourne, and there was the gas pipes still up in the ceilings.
Well, that's it. You go into some really old houses and you can still see the fittings on the wall for where a gas lamp was.
Yeah. Yeah. Yeah, no, I suppose it was another way of gas ovens when they came in. A few people tried to put their heads in them over time, but whether they were successful or not, I don't know.
Unfortunately, coal gas, yes, you can. Natural gas, no, you can't.
No, just get a headache with the natural gas.
Yep.
Yeah. Any more questions? No, you've done well, Mark.
I just noticed a comment. There are a few gas lamps around. I live in Mount Victoria up in the Blue Mountains, and about 20 years ago, they actually put gas lamps back in the park. So on a foggy night, it has a real Victorian atmosphere. If you walk through the park, there's the gas lamps glowing and the fog swirling around. And
yeah, I think there's 1 or 2 gas lamps in the streets of Melbourne that have been put up for sentimental reasons. Yeah.
Mark, it's Robert Bushby here from Tasmania. That Telfer system looks horribly complicated. You got any comments about the maintenance and the operation of that?
Well, that's what was replaced in the 60s with a conveyor system.
With a conveyor belt, yeah.
Yeah, but it had operated by then for almost 50 years. And it was only after 50 years of operation that they really started to have maintenance problems with it and replaced it with a conveyor system. So it looks complicated, but really it was a very simple system and could operate reliably day in, day out, forever.
Yeah, it looked like it was sort of very over-engineered by modern standards, so that's probably why.
I was told the other day there was a Telfer system at the Associated Smelting Works at Port Pirie, but I haven't had a chance to look into that to see if that was the case.
Yeah. When you were talking about
thanks,
the Telfer
Mark.
system,
Great presentation.
Yeah.
Thank you.
Yeah, Mark, when you were talking about the Telfer system, it reminded me of the similarities with the profession I was in, railway signalling, and just the blocking out of the sections behind it to avoid a second bucket coming in.
It's as you said, colour light signalling uses the same system to an extent.
Yeah, and the interlocking arrangements for those overhead points and so forth. Yeah, no, it was quite interesting. But it's system processes. I suppose it's on all sorts of things. Yeah, no, very interesting. Thank you.
There was a Telfer system used at the BHAS at Port Pirie, the lead smelter.
Well, that's what I was told the other day by Neil Hogg, if you know Neil, but I haven't had a chance to do any research to see if there was a Telfer system. He reckons you can go on Google Earth and still see traces of it